In my last video, I have explained about principle and theory of flame photometry. Okay, in this class, I am going to explain instrumentation of flame photometry or instrumentation of flame photometer. Okay, here you can see this is the black diagram of flame photometer. Here you can see the parts. Here this one sample solution. You can see sample. Okay, here sample. Here this is the burner. Okay, here this is the whole part is the burner. Here, if you need to understand the burner means we need to know about the fuel and oxidant ratio and the properties of flame. Okay, then collimating mirror, prism, photometric detector, amplifier, and meter. Let's see the working principle of flame photometer. Here, the first one is the sample solution. Here, the sample solution reaches to the flame. How it will reach to the flame? First, the sample solution converted into the liquid droplets. Okay, then after from the liquid, from the droplets will be evaporated and converted to the fine residue, that is due to thermal energy of flame. Then the fine residue will undergo decomposition and converted to the neutral atoms. So the sample solution reaches to the flame in the form of neutral atoms, that we have seen in the principle. Okay, here whenever neutral atoms reaches to the flame, then what will happen? Here, due to thermal energy of flame, the neutral atoms undergoing excitation. The neutral atoms undergoing excitation, and the excitation is unstable. It return to the ground state with emission of radiation. So here neutral atoms will emit the radiation. It will emit the radiation. This is the emitted radiation. This emitted radiation will fall on collimating mirror. Okay, the property of mirror is reflecting. Okay, whenever emitted radiation from neutral atoms falling on mirror, it reflects towards prism. Okay, it reflects towards prism or gratings, whatever we are using. Okay, here prism, whenever it is falling on prism, it will disperse the light radiation. Okay, then from the prism, it will fall onto the photometric detector. Here, the detector will detect the intensity of emitted radiation by the sample. That gives information about the concentration of the sample. Here, what are the photometric detector? Either it may be photovoltaic cell, photomultiplier tube, or photo tube. Okay, then it will amplify the signal. This is about working principle. Okay, let's say flame photometer consists majorly 5 parts. Those are first one, sample delivery system. Sample delivery system means sample should deliver the flame. Okay, flame. It consists nebulizers. Sample delivery system consists nebulizers. Remember that. Then burners. Then in the burners we have to explain about flame and fuel and oxidant ratio and types of burners. Then collimating mirror. Then fourth part is monochromator. That may be prism or that may be grating. In simple flame photometer, prisms are used. In expensive flame photometer, gratings are used. Okay. Then detectors. What are the detectors? Here photomultiplier tube, photo emission tube. Here among the photomultiplier tubes are most commonly used in flame photometry. Okay, let's see one by one. First one, sample delivery system. Okay, sample delivery system means how sample will deliver. It is delivered by the process of nebulization. Important thing. Okay, it is delivered by the process of nebulization. What is meant by nebulization? Okay, here nebulization is a process of conversion of solution into mist. Conversion of solution into mist of droplets. Conversion of solution into mist of very fine droplets through a jet of compressive gas. Jet of compressive gas is known as nebulization. Okay, in simple thing you just remember solution is converted into the fine droplets. Solution is converted into the fine droplets. Okay, here that is the thing we have discussed in the principle only. Okay, solution is converted into the very fine droplets. How? Through the jet of compressed gas. That process is known as nebulization. Okay, in the sampling delivery system, the solution whatever taking that is converted into the fine droplet form. Okay, here that is the process of nebulization. Here it is done by 3 types of nebulizers are available. 3 types of nebulizers. Those are pneumatic nebulizers, electrothermal vaporizers, ultrasonic nebulizers. These 3 types are used. Among the pneumatic nebulizers are most commonly employed in flame photometer. Most commonly employed one is pneumatic nebulizers. Okay, this is about sample delivery system. Okay, solution is converted into the mist of very fine droplets. Okay, keep in mind. Here droplets are formed here, right? Then next one is burners.
Okay, here burners are used to convert fine droplets of sample solution. Fine droplets of sample solution into the neutral atoms. Remember, fine droplets of fine droplets of sample solution into the neutral atoms. In the sample derived system, fine droplets are common. These fine droplets, by the using of burners, these fine droplets are converted to the neutral atoms. These neutral atoms will reach the flame. Okay, that you keep in mind. Okay, burners are used to convert fine droplets of sample solution into neutral atoms. Okay, these neutral atoms further undergoes excitation and emission of radiation at particular wavelength. Okay, due to the thermal energy of flame, these neutral atoms are undergoing excitation. Okay, here excitation is unstable, return to ground with emission of radiation. This emission of radiation we are going to measure at particular wavelength. Okay, here then what are the ideal properties of flame? Here, okay, the properties of flame, ideal properties. Every flame should consist these following properties. What are those? Here, the flame should ability to evaporate the liquid from the droplets. Okay, here the flame must be evaporate the liquid from the droplet. Without evaporating, here fine residue may not form, and these are not converted to neutral atoms. So, the flame should evaporate the liquid from the droplets. Okay, and second property, it should decompose fine residue of sample into the neutral atoms. Okay, after evaporating, here fine residue is forming. This fine residue should convert it to the neutral atoms. It can be done by flame only. Okay, that is decomposition with the help of flame. Then third property, ability to excite the atoms. Ability to excite the atoms and cause them degradation. Means, okay, due to the thermal energy of flame only, the neutral atoms gaining energy and undergoing excitation. Okay, here the flame should have ability to excite the atoms and cause them emission of radiation. The excited atoms will emit the radiation. These three properties must consist the flame. Okay. Next one, as I told you that then fuel and oxidant ratio. Fuel and oxidant ratio. Here, if the temperature fuel and oxidation ratio is very important in case of temperature of flame. Okay, why? If temperature of flame is low, then what will happen? It may not cause excitation of atoms. If it is low means here these atoms may not undergo excitation. Without excitation, they cannot emit radiation. So it is not good. Okay, if temperature of flame is high, it is also not good because it may cause ionization of the sample. Okay, it may cause ionization. Here ionization also not important. Here it should be converted to the flame. It should convert it into the neutral atoms. So if the temperature of flame is low, that is not good. If the temperature of flame is high, it is also not good. So to maintain optimum temperature, selective combination of fuel and oxidant ratio should be used. Okay, to maintain optimum temperature of the flame, selective combination of fuel and oxidant should be used. Because if it is low means here excitation will not be occurred. If it is high means temperature of the flame is high means here it is undergoing excitation, ionization. So both are not good in case of flame photometry. So optimum temperature of the flame should be maintained. That can be done by using fuel and oxidant ratio. What are the combinations? What are the different types of fuel and oxidant? Okay, ratio and their temperature. You can see here fuel is hydrogen. If hydrogen is used along with the oxygen, that is oxygen. Okay, here fuel is hydrogen, oxidant is oxygen. If you use both this combination, we will get temperature about 2800 degrees centigrade. Here fuel is hydrogen. If you use oxidant is air, we will get 2100 degrees centigrade. If you use acetylene as a fuel and oxygen as a oxidant, we will get 1600. If you use acetylene as a fuel and air as a oxidant, we will get 2200 degrees centigrade. If you use acetylene as a fuel and dinitrogen oxide, so we will get 3000 degrees centigrade. And if you use propane as a fuel and oxidant as a oxygen, we will get 2800 degrees centigrade. Then propane plus air, this combination of fuel and oxidant will produce 1900 degrees centigrade. Okay, here based on the combination of fuel and oxidation, temperature will be produced. Temperature is dependent. Okay, the temperature of flame, it depends upon the using of fuel and oxidant ratio. That is the thing. Okay, then third thing you can see here, types of burners. Actually, okay, here we have four types of burners are used in flame photometry. What are those? First one, Mecker burner. Second one, total consumption burner. Okay, third one, Premix laminar flow burner. Fourth one, Laminar graph burner. These four are the burners. Okay, types. Actually, burners are used with the combination of fuel and oxidant ratio, for producing a flame. Okay, burners are commonly used with the combination of fuel and oxidant for the production of flame. Okay, let's see the one by one these types of burners. First one is the Mecker burner. Mecker is the scientist name. Okay, here what is the combination? I told you now. Here burners are used with the combination of fuel and oxidant. Okay, what are the? Okay, here Mecker burner. In this burner, natural gas is used as a fuel and oxygen is used as a oxidant in this Mecker burner. Here in this Mecker burner, it produces flame very low temperature. The flame produced by the Mecker burner having very low temperature. So this temperature is not enough for the excitation of atoms. So whatever the flame produced by the Mecker burner, it is having very low temperature. That temperature is not enough for the excitation of atoms. So here flame produced by this burner and not homogeneous chemical also. So that's why it is not widely used in flame photometry. Mecker burner is not widely used in flame photometry because here whatever the energy produced by this burner, it is not enough for the excitation of atoms. That is the first thing. And second thing, here by the Mecker burner, homogeneous flame may not be produced. That is the second thing. Because of these two reasons, Mecker burners are not widely used in flame photometry. Okay. Then second thing, total consumption burner. Simply it is known as TCB. Total consumption burner. Here in this burner, hydrogen is used as a fuel and oxygen is used as a oxidant. Fuel and oxidant ratio. Hydrogen and oxygen. Okay. Here it is a black diagram of total consumption burner. Here it is a sample solution. Here this is the sample inlet. Here you can see here by this way oxygen is entering, by this way hydrogen, by this way oxygen is entering. Okay, here this is the flame. Here inside this is the base of the flame. Here at this position, whatever the oxygen, that is the oxygen aspirates samples into the base of flame. This is the construction of total consumption burner. Let's see the working and importance of TCB. Here, first point is this one. Hydrogen is used as a fuel. Oxygen is used as a oxidant in this TCB. And second point is from the side tubing, hydrogen and oxygen enter and both are burning at the top and produce flame. Here as I told you that hydrogen and oxygen from the side tubing, hydrogen and oxygen are entered, and both are burning at the top. Here it will reach to here and burning at here and produces the flame. Here third point is as soon as the sample solution drawn into the base of the flame, the oxygen aspirates the sample solution, leaving solid residue. As soon as sample reaching to the base of the flame, here what will happen? Here the sample will be converted into the neutral atoms. Here sample is converted to the solid residue. Means here whatever the liquid present in the droplets will be evaporated, so residue will form. Then due to the thermal of flame, here this residue will be undergoing decomposed to give neutral atoms. That is the thing. Then fourth one, then after solid residue forming, what will happen? Followed by atomization and excitation. Atomization means here after forming solid residue, this decomposed to give atoms, neutral atoms will be produced. Then after forming neutral atoms, then excitation will be occurred. Followed by atomization and excitation of atoms will be takes place. Then last one, here the name of TCB, why it is known as total consumption. Name itself indicates total consumption. Why? Here the name TCB used because all the sample entered into the capillary tube. All the sample, whatever we have taken, all the sample entered into this capillary tube. Okay, this is the capillary tube. Okay, will enter the flame regardless of droplet size. Here all the sample which is entering into the sample inlet will reaches to the flame or will enter into the flame regardless of droplet size. Means nothing but actually only small droplets only reaches the flame. Larger droplets will drain away, will gone away. Actually in this total consumption burner it will not be occur. Regardless of droplet size, it will whatever the sample entered into the here inlet, it will reaches to the flame. All the sample here you can see. Here all the sample entered into the catalyzer. That's why it is total consumption. Total means all. Okay. Then disadvantages of total consumption burner. What is the disadvantages? The flame produced is noisy and turbulent. Whatever the flame produced by the TCB, that is noise and turbulent. That is nothing but not uniform in manner. Okay. Homogeneous flame is not obtained by the TCB. Homogeneous and uniform flame is not obtained by the total consumption burner. These two are the disadvantages of total consumption burner. Okay, and third thing is, third type of burner is very important one. Premix laminar burner. Premix laminar flow burner. Okay, here it is widely used. It is widely used in flame photometry. Widely used in flame photometry. Here the name is indicated premix. Here before it is mixing. When it is mixing, you can see here in this fuel oxidant. Whatever you are using, fuel and oxidant and sample solution, aspirate sample solution thoroughly mixed. Okay, fuel and oxidant, the sample solution thoroughly mixed before reaching the burner head. Before reaching the burner head, the strip will be thoroughly mixed and then enter into the flame. That's why it is known as premix. Here before reaching the burner head, they are mixing together. That's why it is known as premix. Okay, this is the black diagram of premix laminar flow burner. You can see here this is the sample solution. Here by this way aspirating air, and this is way entering into the oxidant. By this way fuel will be entered. Here this is the burner head. This is burner head, and the burner head flame will be produced. This is the flame. Here these are the mixing buffers. I told you now, here fuel and oxidant and samples are mixing together by the process of these mixing buffers. Okay, when here the sample in the form of droplet size or neutral atoms will reach to here, oxidant and fuel will come to here. Both will be mixed by all this will be mixed by mixing buffers before reaching into the burner head. That's why it is known as premix. Okay, then you can see only small portion, that is 5% of sample in the form of fine droplet reaches the flame and easily decomposed. Here about 100%, only small portion of sample, that is only 5% of sample, that sample it reaches in the form of fine droplets in the flame. Okay, it reaches to the flame in the form of fine droplets. It reaches to the flame in the form of fine droplets. Only 5%. Then then it can be easily decomposed. This is the important feature of premix laminar flow burner, because only small portion of the sample in the form of fine droplets reaches the flame and easily decomposed. If you see total consumption, here regardless of droplet size, they are reaching in the flame. Okay, they are reaching to the flame. Here only 5% of sample reaches in the form of fine droplets. Here this remaining 95% will drain off, will be removed. Okay, here you can see here easily decomposition. What is meant by easily decomposition? Easy decomposition nothing but efficient atomization in flame will take place. Okay, whatever reaching to the flame, here they will undergo atomization very efficiently. Efficient atomization in flame will take place. Then larger droplets from this aspirator are impinging of spray chamber and drain off. Okay, here this is the drain way. Okay, the larger droplets will remove from this way. Okay, remove from this way. Okay, will be drained off. Okay, larger droplets. Then what are the advantages of premix laminar burner? Okay, means flame produced by this burner is noiseless and non-turbulent and stable. Noiseless, non-turbulent and stable. I told you that it is a widely used in flame photometry because of this one. Here noiseless, non-turbulent and stable, and easy decomposition of sample takes place. The second advantage is easy decomposition. If you see in total consumption, flame produced here noisy and turbulent. That's why it is not used regularly. Okay, here the flame produced by premix, it is noiseless and okay, non-turbulent and stable. This is about premix laminar burner. And last one, Laminar graph burner. Laminar graph burner. Here this is the black diagram. Here by this way larger droplets are rained away by this way. Here in this way spray chamber, sample and oxygens are mixed. Sample and oxygens are mixed here. Here by this way sample is entered. By this way oxygen is entered. Here both are mixed here. Then by this way fuel is entered. Fuel tube. Okay. Here this is the flame. Okay. Fuel. This is the black diagram of Laminar graph. Laminar graph scientist name Laminar graph burner. Then we can see working in this burner. The sample must be liquid. Okay, if the sample is liquid only, then we can use Laminar graph. Solid samples, gaseous sample cannot be analyzed. Okay, this burner is associated with spray chamber. It consists of spray chamber. Okay, associated with spray chamber. Large droplets condense on the side and run away. Okay, I told you now, large droplets are condensed here. By this way sample is entered. Okay, here after entering, okay, large droplets are condensed and drained away by this way. Okay, then small droplets are vaporized. Okay, vaporized samples are swept in the base of the flame in the form of cloud. Here small droplets, okay, and vaporized samples are reaches to the flame in the form of cloud. Okay, small droplets and vaporized sample. Okay, here various devices have been used to enhance the nebulization state. This is the important thing of Laminar graph burner. Here various devices are using for what? To enhancing the nebulization state. Nebulization nothing but sample solution. Liquid solution is sample solution is converted into the neutral atoms. Sample solution is converting into the fine droplets. Here to improve that nebulization process, we have to use several devices. What are those? Impact bed, ultrasonic vibrator, thermospray heaters. These three are used. Okay, this is about lantern. Okay, this is about types of burners. Okay, burner. And third one is collimating mirror. Okay, third part of this instrumentation is collimating mirror. Okay, here in order to maximize the amount of radiation, used for analysis, okay, the mirror is located behind the burner. To reflect back to the prism. Why this burner why this mirror is keeping backside of the burner means to maximize the amount of radiation used for the analysis. Okay, here the mirror located behind the burner to reflect back to the prism. Here you can see in the diagram. Here this burner is behind to the this mirror is behind to the burner. Here to maximize using the maximum amount of radiation entered by the sample. Whatever the radiation entered by the sample will directly fall onto the mirror and whenever this falling on the mirror reflected back to the prism. So using a maximum amount of radiation, we are keeping the collimating mirror backside to the burner. And fourth part is, as I told you that, and monochromator, that is prism. As I told you here in simple flame photometry, nothing but in simple inexpensive flame photometer, prisms are used as a monochromator. In expensive, here costly equipment or expensive flame photometer, gratings are used. Here I already mentioned how prisms and gratings will be worked in UV visible spectroscopy. Okay, once you go through there. Then detectors. Okay, next part is detector. Here detector will detect the intensity of emitted radiation. Okay, here what are the detectors we are using? Photomultiplier tube, photo tube, photoemissive tube. Among these, mostly we are using photomultiplier tube in flame photometry. Okay, it will convert the radiation into the electrical signal form. Okay, as I told you. That's why these are known as photometric detectors.